Okay, today we're going to analyze winter 2018 question 5 to question 1a. Okay, we're just going to analyze this particular question only. So now they say that a sample of wastewater have calcium, copper 2 plus, and lead 2 ions. Now, the key word from here, right, I want everybody to take note is that you are to separate the metal ions, okay, by forming precipitates of the metal ions. So you have to separate 1, 2, and 3. Okay, 1, 2, and 3. Okay, so now, they give you the KSP, the solubility product, which is actually the concentration of the ions times together with their power. Now, I want you guys to read these key sentences right here, which is the smaller the solubility product, the easier for it is for precipitate to form. That means the smaller it is, okay, that's the first one that will form a precipitate. Okay, so now let's rank them. Okay, let's rank them. So for the first one, right, this is smallest is right here, number 1, followed by here, number 2, number 3. Okay, so if there's a chloride anion, you put lead. Lead will be the first one to precipitate out, followed by copper, followed by calcium. In this particular case, for carbonate, it will be 1, it will be 2, and it will be 3. Okay, now for sulfide, it will be 1, it will be 2, and it will be 3. Okay, okay, so do take note what we learned from this one. Okay, so for sulfide, for calcium, calcium ion is the hardest to precipitate. Please remember that, because look at this 1, 2, and 3. 3 means it's the higher solubility product, harder for the precipitate to form. Okay, now generally speaking, lead ion is the easiest to form other than with sulfide. Okay, and then only in sulfide will copper is the strongest. So remember, only in sulfide ion, with sulfide ion, copper 2 ion is the easiest to form precipitate. Okay, so do take note of this. Now you have a clear idea of this. Now let me save this. Okay, okay, good. So now remember, calcium 3, lead 1, copper is only 1 with sulfide. Now let's look at this particular flow chart. Again, please remember what you are trying to achieve right now. What you are trying to achieve is you're trying to to uh, to remove off the metal ions. You're trying to separate lead, copper, and calcium from each other. Okay. So now when you add chloride right that time, right? Let's go do this step by step. Which ion will be the first one to precipitate? So just now what we observed from the previous one, please check the video back. It is lead ion will be the easiest. So makes sense, no? So now after you added the lead, right, you're going to form a lot of lead chloride. It's going to form the solid precipitate out. You can remove it with filtration. So now in the solution, there is now copper 2 and calcium ions only. Okay, so now the solution ready, right? We already removed the lead. Now we want to remove the copper and the calcium. Okay. Now the next question I want you guys to think about is then what do we add next? Do we add the sulfide or do we add the calcium? Do we add the sulfide or do we add the calcium? Okay. Okay. Now think about it. At the end of the day, uh, you can actually say, sir, I want to add the either way, right? You add the sulfide or add the carbonate, right? Copper is going to come out first because calcium ions least, okay, hardest to form precipitate. Okay, okay. With that being said, but sir, why the answer only accept sulfide here? Why they don't accept carbonate? Okay, so if you put carbonate here, you're going to form copper carbonate, and then here left remaining will be calcium sulfide. The answer lies in okay. I want you to observe for uh, copper versus calcium with carbonate and with this sulfide. Notice that the difference in the sulfide 10 to the power of negative 36, 10 to the power of negative 10. Notice the difference between copper and calcium 10 to the power of negative 10, 10 to the power of negative 9. Because these two numbers is very close to each other, so if you add a little bit too much carbonate, you are also gonna get out calcium carbonate. Makes sense or not? Because the numbers are very close to each other. So some of the calcium might precipitate out. So that is why we add in sulfide first. Because we add in a little bit of sulfide, all the copper is going to precipitate out. Solubility product so low. We won't worry that a little bit of calcium will precipitate with calcium sulfide. Whereas this one, if you add in carbonate first, we will worry about that. That's why. So sulfide is added because the solubility product is very low for copper to sulfide. Therefore, what's left remaining is calcium. Therefore, you add in the carbonate, you're going to form your calcium carbonate. With that being said, thank you very much.